What's the rule? If the professor doesn't show up in 10 minutes, class is canceled for the day?
That seems like to be the case usually. But isn't that because people don't want to be in the class, but we
That's
sort of want to be here? It's either that everybody's watching England and Germany play.
Looks like there's nothing on the agenda.
Yeah.
Well, I'll just introduce myself since there's nothing else on the agenda. My name's Trent. I'm from Salesforce. I work on like the CI/CD team there. I'm just joining to kind of listen in, see where I can jump in and help. Got a lot of background in ops and Golang, and so it looks like you guys work on a lot of code things. So any suggestions on where I can jump in or whatever would be great. But I assume there's a lot on the board here, so should be a lot of opportunity to help out. But
yeah, welcome, Trent.
Thanks.
Yeah, there's definitely a lot of need. One of the biggest things that we've been dealing with is flakes, just tons of like intermittent flaky testing. And a large part of that's just coming from the nature of, a distributed testing environment. And so it's a lot of timeouts and stuff. And we're coming up on code freeze right now, but hopefully that will lead way to a little drilling down into, more reliability. Oh, there's Ben. Hooray.
Is that mostly in Prow?
Yes.
Mm-hmm. Okay. So is it just wrapping a bunch of calls with back off and retries?
No. Yes. I think it's the root of it we have to drill down into.
Yeah.
Hello, Ben.
Hi. Sorry about that, y'all. Bad timing this morning.
We are about to invoke the 15-minute professor rule if the teacher doesn't show up.
I guess I know Aaron was probably not going to make it, impacted by the Pacific Northwest heat wave this year. I would imagine the same is also likely for Steve. So welcome, everyone. Sorry I'm super late. This is the Kubernetes SIG testing meeting for June 29th, 2021. This meeting is under the CNCF Code of Conduct. Essentially, be excellent to each other. This meeting is recorded and will be posted to YouTube at a future date. So usually we have a hard cutoff for agenda items ahead of time. The day before, there's a calendar entry for that. And we would announce that the meeting was canceled if there's no items. But we didn't have the template entry in the notes this time, so I thought we ought to just meet anyhow, given that there wasn't a good place to add them. People may have been confused. So if you have any topics, please go ahead and add them to the doc now, so that we can at least sort of go through them in some sort of order. That doc is linked at the top of the SIG testing Slack channel in the description of the room.
Thanks, Ben. Really, I just came in to see what was going on and what I should be involved in.
Great, yeah. I don't know, like I said, we don't have an agenda today, so I can discuss a bit about that, but depending on what everyone else is here for or may be interested in, it might be better to follow up offline about that. just give a moment for any agenda entries. Okay, so sure, let's start on that. So if you're looking to get started in the SIG, definitely, come to our Slack. I think it's the most active part of the SIG by far. Like we have the mailing list, we have the Zoom meetings, but you'll find most activities happening in Slack or GitHub. So join our Slack. It's SIG testing in SIG-testing in the Kubernetes Slack. And from there, I'd say we have github.com Kubernetes SIG testing. So this repo is where we're starting to document some of these things. We've been experimenting with GitHub discussions, so I'd say that experiment is not going well, but so you're aware they're there. And we have some issue tracking that is sort of like SIG issues that aren't really repo specific. One of them is actually about how we need to surface the project boards better. We have a project board in Kubernetes and a project board in the Kubernetes SIGs org, Kubernetes-SIGs. Kubernetes-SIGs is where SIG subprojects go that aren't more or less legacy stuff that's still in the Kubernetes org. Pretty much all new endeavors are there. Unfortunately, GitHub projects can't track issues cross org. So we have one for each org, and you'll find in our project boards that we have a help wanted column, and we attempt to make sure that any issues that have been tagged as help wanted that are relevant to the SIG are added there. I wouldn't say it's 100%. Another thing you can do is go to our repos. Those are documented in, if you go to the github.com Kubernetes community repo, the community repo in the Kubernetes org, there is a doc listing all of the SIGs, and there are subfolders for the SIGs. There's a doc there that lists all the subprojects. The subprojects that we own, like Test Infra, will all use the help wanted and good first issue labels where appropriate. And then we are currently manually sweeping through those and making sure they're in the project board as well. But the most up-to-date thing is just the issues directly. So you can do a GitHub search in those repos as well. And maybe take a look through those repos and see if any of the projects interest you.
Is that, you said there's two boards? I got the projects 52 board. Is there another one?
There's another one in the Kubernetes SIGs org. Let's see. I think I linked back to the Slack discussion where we had it. So you grab that. But it's also called SIG testing. It's pretty much the same thing, but it's in the other org.
Oh, confusing. Yeah.
Yeah. I did not.
So it's not 52, it's the other one that you're talking about.
Yeah, because those numbers are just it's just an auto increment on adding projects.
Yeah.
So there's no good way to. It's 11 in the other org.
Okay.
Oops. Down. Go. So here we go. Like I said, currently at the moment, that's Aaron and I going through and more or less going through and like manually adding things to this board. There is a little bit of automation for like, if an issue's closed and moves through the board, but so the help wanted things there should be pretty good that we've like gone back over and identified again as like, yes, this looks like a help wanted issue. But if you're looking for more, there are definitely issues that haven't made it into the board like since our last pass through. And this topic is also something else that we are looking to do. So in the SIG testing repo, I have another issue filed about improving issue triage and how we might do that. One thing that comes to mind is there's a tool triage party that basically hosts a custom web page for doing triage workflows, sort of multiplayer, and having a bot enact the actual changes on GitHub. Some parts of the project have experimented with this. It originated from Google's Minikube team. So we ideally don't just want to like explore this for SIG testing, but we want to explore how with workgroup Kate's Infra, if this tool works well, we can sort of make it easy to stamp out for other SIGs or just go ahead and host in more instances or so on.
What's that called?
Triage party. And the tracking issue is here. I'll link it in the doc. Oops. There we go. Issue number 7 in the SIG testing repo. And that also came out of a discussion that I'm having about a bot that we own the source code to, but the policy is owned by the contributor experience SIG, which is also sort of generally how the dynamic works in Kubernetes, that automatically labels stale issues and closes them. I made the mistake of locally complaining a bit about this and started a large discussion about it recently. So one of the more productive things we can do is try to improve issue triage so that we sort of can keep up with incoming issues better. So rolling out like providing tooling for that sort of thing is in the scope of the SIG. We pretty much do project infra tooling, particularly as it relates to CI and GitHub. Contributor experience, though, is sort of responsible for like the workflows at this point, and like how should we be behaving as like processes and things around GitHub. And then there's also worth knowing there's a work group, Kate's Infra, that span out of so a lot of the infrastructure came out of a team that I was on, though started before me at Google, that sort of set up all sorts of things for the project early on. So like CI infrastructure, image publishing, and because that was just kind of done real quick in a convenient way to get the project going, it was all in projects that are like under Google's Google Cloud organization. So they're not really accessible to the community because they're like Google internal. So maybe 2 or 3 years ago, one of the more prominent Googlers, Tim Hawken, arranged a large like credit donation in the CNCF, so we could basically, instead of like billing it to Google through Google projects, we can have like credits to the CNCF, and then CNCF hands them to steering, and then steering hands them to workgroup Kate's Infra, and then we set up some GCP projects in a Kubernetes.io organization. And then if you want to like have access to any of the resources, that's all controlled with like YAML in GitHub and Terraform and Bash. And we are like migrating things there. So whenever we're standing up new infra in particular, especially, we are looking to collaborate with that work group and make sure that, we're doing this with their resources, so that it will be like a sustainable thing that the community can collectively manage.
Right.
Instead of something one of us set up on our own. Sorry?
What repo is that? All the infra? pieces? Or
So yes, the bulk of it is in the Kubernetes/kates.io repo. Originally, that just had some things like there's an Nginx instance that handles things like go.kates.io/shortcuts that go to different things. But now it has we use Google Group Management. Kubernetes has like a G Suite instance, so we have Google groups that we use for like these are the owners of this thing, and then we're able to do things like synchronize that to RBAC rules within clusters that we run for the project, or access controls in Google Cloud. Most of it is in Google Cloud because of that like large credit donation, but
Sure.
there's also some management. There are some things like there's some AWS accounts that are managed for some end-to-end testing. In particular, a couple of the sub projects use like KOps. So there's a little bit of the code for that there. Some of the other code for like the tools themselves are in repos like test infra, but pretty much all of the like definition of like deploying the infrastructure is now in the Kates.io repo,
Okay.
along with things like images. If you want to publish an image to our Kates.gcr.io, then you like PR a manifest there.
Sure.
And that's also the trend that we use for pretty much everything, and something that like SIG testing has been pretty big on pushing is that pretty much everything is to the extent possible managed declaratively, just like you would in Kubernetes, where you're going to like send a pull request to like a YAML file that says like this person should be a member of the GitHub org, this person should be in this group, this like image should be published, this infrastructure should be deployed, this domain name should exist. We have kind of gone all in on pretty much everything is declarative YAML to the extent possible.
Yeah.
Some things are still like, you know, some bash scripts that haven't been replaced yet, or some Terraform.
What's the backend that drives all that?
We have a number of custom things. So for example, like domain names, started with OctoDNS and a bash script, but now we have something that like reads a simple YAML spec that we came up with and maps that into that. So there's various tools that are sort of like ad hoc reconciling these things, and there's some that are doing it continuously, and some of it is just like off the shelf stuff like Kubernetes or Terraform.
Okay. Okay. So it's kind of like, yeah, it's a mishmash.
Yeah, it depends on the tooling. So like, for example, for all the GitHub management, we needed to build a tool because I mean, most people are doing this manually, which is, you know, pretty easy to do, low friction if you have some admins, but we've strived to have just a very few folks that actually have administrative permission over everything. And then pretty much everything else is delegated through robot accounts and, you know, publicly auditable. You can go see like, okay, we added this person to the organization here, that sort of thing.
Yeah. Yeah. Well, that makes sense. So pretty modern DevOps approach, I would say.
Yeah, I mean, a number of the leaders in the community really want to like, you know, we want to be doing what the project says, that like, okay, declarative management makes sense, so we should declaratively manage everything. And I'd say the project's doing pretty good at that. Generally, if we stand up some infra tool, there is like some declarative spec for what it's doing. So that kind of is like the project level infra. There are the testing infra. I give a pretty quick rundown, but I might actually want to point you to like one of our talks at KubeCon or something like that to go.
That's fine too. Yeah, sure, absolutely. Anything.
The gist is we had a Jenkins. That was another one of those things that like Kubernetes just sort of set up, and then over time they started containerizing workloads on it for like easier setting up the correct environment, that sort of thing. And they had some issues with like the GitHub integration for triggering and things. So someone built a little webhook handler that would watch for GitHub webhooks and like kick off Jenkins jobs.
Sure.
Then we had a YAML spec for that. And then somebody realized, okay, we're doing YAML to create containers. Why don't we just like run these on a Kubernetes cluster? And since there was a Google team doing most of this, we just set up a GKE cluster. Like, great, no more managing clusters, just schedule pods. And now pretty much most all of the CI looks like that now. you sort of write a pod spec, and then some additional containers are injected to do things like code checkout or upload the results. And we have some like YAML that describes like this is a pre-submit job, it runs on PRs, or this is a periodic, it runs on this schedule. And then we have some like web dashboards for viewing the results, and pretty much all of that works by uploading things to a GCS bucket, and where possible we encourage people to produce JUnit XML, and then we have sort of like structured results that various tools can read. So for example, we have a tool that goes back through all of these results and does some BigQuery queries and then some further processing, and produces a dashboard of like what are the most common like error messages we're actually seeing across all of our jobs.
Yeah.
So that you can start to identify like, okay, we started having this failure mode spike at this point. We had a bad change go in.
Awesome.
That is, put that in the chat. So almost everything revolves around this. Like we use containers and like Kubernetes clusters to run things, and then we produce pretty much all of our results as files on GCS that are either JUnit, which was something of a standard, or some JSON files that contain some metadata about like when we started it and like which job it was, that sort of thing.
Yeah.
And then there's something of a spec for that in test infra, and then a bunch of different tools are able to like consume those results and process them. We also have a service that is partially open source and Google operates, called TestGrid, that we use for sort of like historical, this job has, here's the results over time, with all the individual structured results as rows. And so that's used pretty heavily by the project. Like releases are pretty much, there's a dashboard of these jobs must be green to release, and they're running periodically against the branch we're developing. And then there's like a team that monitors those and says, okay, we have this important, I don't know, unit tests are not passing. Oh no, we can't release, and like file issues and fall through that. So we also work quite a bit with SIG release there on that sort of thing.
Yeah.
So like similarly, we provide most of the tooling for this, and I think we provide quite a bit of direction on like what those jobs are. But at the end of the day, like if you want something to be release blocking, we some SIG testing folks wrote the policy, but it's owned by SIG release, and you need to go talk to SIG release. So like kind of similar to Contrabex, might be building stuff, but like we're working directly with other SIGs for like the ownership model, all these things.
Right. So it's more like this team's more like providing the tooling and the infrastructure and the automation, but not the process per se, right? The process is more for SIG release.
Yeah. So
okay, cool. Yeah.
Honestly, if there was enough
then.
return on investment for it, I would be being harder to sort of like rename the SIG. A lot of people come to us and assume we just like write all the tests.
Yeah, I know. That's what I thought.
No one does that. No one wants to do that.
I know.
Write your own tests. We'll help you like figure out what you should do.
Yeah, it should just be SIG CI CD or something. I don't know.
Yeah, I think it came out of one of the things that was early on was like the end-to-end test framework. But at this point, there's really not that many folks working on that directly. It's one of those things where like you kind of improve it a bit when you need to use it, but like no one's actively like that's not their day job or anything like that, where they're like main focus. People are working on like the infrastructure mostly than this SIG. So we have a lot of overlap with Workgroup Kate's Infra. They kind of like own the credits and sort of like the broader like maybe some of the infrastructure that isn't remotely testing oriented, like the domain names and stuff. But again, you'll find like if you look at the like leadership between the groups, there's a lot of overlap. Like Aaron is a lead of both SIG testing and Workgroup Kate's Infra and doing a lot of things there. Or you'll see, I think, yeah, Arnaud is in this call and is a lead of that group and is also pretty active here. I will follow up offline with some more places that you can get context.
Yeah.
Since we've
thanks for that.
Some time on this. If anybody has any questions, answer them, and then otherwise, I I think we should move on to the next agenda item.
Actually, hi, Mariana. I want to be a contributor. I'm just lurking at this moment, and I was late to the meeting. I saw the notes, and I was wondering what did you say were the tags that were supposed to be looked at for new contributors or beginners? Was it just help wanted, or was it specifically for new? I remember there was a tag for new people.
Yeah, so throughout Kubernetes, this is pretty standardized. There's a help wanted tag, and then there's an additional good first issue tag.
Yeah.
There are strong rules that are expected by the project around what is a help wanted issue. Like if you're asking for help, there should be some pointers to like what actually needs to be done, and it should be an issue that some folks that are active in the project have like agreed to. Like there will be support for actually taking this action. It's not up for debate still. Good first issue is a bit looser, but is applied by folks where they think like probably this is a good starter issue. And those are also labels that GitHub itself considers standard. So I think there's actually a page in GitHub that's a little obscure on repos that will like point you to these issues. Let me pull that up.
Cool. But if there's like some sort of like offline more info sharing, I want to subscribe to that.
Oh yeah, sorry. I just
wanted to raise my hand.
I'll pull up some of those resources and pass them along. I'll do that in the SIG Slack, I guess, and try to poke the right folks there. I would share them here, but I probably need a little bit to dig those up.
No worries. And again, I'm still kind of overwhelmed by the hugeness of everything, and I haven't decided where to go and everything. That's why I'm kind of lurking.
Well, welcome. And honestly, the overwhelming doesn't totally go away. The scope of this project is pretty massive. The infrastructure itself, I'd say, is a little bit madness. We run a lot of stuff ourselves, but a lot of it also just comes because a lot of off-the-shelf stuff for like, I don't know, doing GitHub doesn't really scale up to like 200 repos and like 1,000+ contributors and all that jazz, or like our big end-to-end tests or things like that. The project tried really hard to use off-the-shelf stuff, but
that's also cool because it's problems you may not see elsewhere. So some fun things to solve.
Yeah, thanks. I also have Eddie's talk on. I want to look at it at some point. Didn't get to it yet. I saw you there.
What talk?
I also lurked on the CLI channel, and you have like a thing where you talk about contributing as well.
Oh, the LGTM from last week.
Yeah, that one.
Gotcha. Okay.
Yeah,
That's a good walkthrough of Kubernetes. Yeah.
Do you want to add a link to that in the SIG meeting notes?
thank you all for contributing to the notes as well. Usually we have someone taking notes, like someone else might be doing the meeting and I'm taking notes, but today we're a little short staffed, so appreciate it.
Yeah, of course.
Okay, well, I will, like I said, I'll post some more links where you can like learn more about the SIG and the infrastructure later today and the SIG channel. And we can also see if we can get some more of these things sort of more centrally documented. I'm hoping that we can, we've only had the SIG testing repo since like maybe end of last year. Hopefully we can flesh out some of the documentation there and have the README kind of point people towards that. Right now the test info repo points you to a bit, but you know, it sort of runs out of scope for things that are no longer part of test infra. So I think hopefully we can get some things like these project boards surface better, somewhere a little bit more discoverable. So So next up, we have Eddie's point about simple pod flakes with network timeouts. Want to talk about that, Eddie?
Yeah, so I know you've been keeping tabs on this one a bit too. As we're hitting code freeze, I just want to know what work we need to scope out for these types of flakes. The original fix was to kind of give it a more of a grace period for the timeout, but we obviously don't want to just keep increasing timeouts for things. So what I noticed for when a lot of these flakes still happen, they happen in batches. So there's like like 12 to like 30 tests that all fail with like a network timeout. Do we have that work tracked anywhere?
I don't think we do. The only thing I can think of is we have some suspicion that that we're still having issues with disk throttling. So like we run, like I said, we run most of our infrastructure on GCP because we have like the big credit donation for that. That's where the infrastructure has been historically. When you run workloads on GCE on like Kubernetes, throttling is done at like the VM level. So if you have like multiple workloads running on a node in a cluster, and they are really, really IO heavy, you can run into like special sort of contention where like the infrastructure is turning around and saying, okay, you're using too much like IOPS, your like IO operations are going to get throttled. And we've had that in the past where like we weren't setting resource requests on things in particular, and we still aren't necessarily everywhere. It's a bit hard to roll that out to all the CI. We have some clusters where we do guarantee that, but there's still no way to request IO. So if you still kind of make the mistake of scheduling multiple workloads to a machine that are IO heavy, they will thrash pretty hard. Or even one workload that's just really IO heavy, like a cluster with multiple nodes with etcd running a bunch of tests. We're running our local clusters. So one issue we do have tracked under Kate's.io is that we'd like to make a new CI pool with local SSDs where like there's actually an SSD physically on the machine that you are running your VM on that is dedicated to you. So there's no throttling, go nuts right to the SSD as fast as you can. Whereas right now, at best, we're using PDSSD, which is like network backed, like virtual disks. We're not certain that that will solve it, so we want to like make a small pool, taint it, allow a couple of jobs to like opt into running there, and see if that improves things. Otherwise, we have just tried to make sure that like all the critical CI is on the newer clusters where we have pre-submit that enforces your configuration must set requested limits, which helps, but it still doesn't guarantee like, we still could be making maybe small requests on something that probably should be making larger ones. So like in particular, the kind cluster testing, we've kind of had some debate still over like how much resources it should really need, because if it weren't for disk, it really shouldn't need many cores to like run some end-to-end tests on there. But I have some suspicion that we're running back into the core issue, and it's not that easy to find because you're going to have to like correlate what we were running on the VM and then look at the like VMs like disk throttling monitoring or something, and not many people have access to that. You can get access by a pull request for like read-only information at GCP pretty easily, but it's one of those things that's like kind of obscure and not that many people have done.
Yeah, I think I'm in that InfoViewers group, and you're actually right. I didn't notice that. I just pasted a recent Prowflake, and it's a bunch of SIG storage and SIG CLI. So these are all ones that are definitely writing to etcd and disk quite a bit.
Yeah, so I'm like fairly suspicious that like what's happening is we're just like hammering etcd and like, well, in this case though, so that only applies when we're running kind clusters, or if we're running like a local integration test, or like builds, stuff like that. In this case, because it's a GCI, GCE end-to-end job, we are like, the only thing that's actually running in those PDSSD nodes is like, we grabbed the binaries and we stood up a cluster, and then we're running the E2E test binary. the actual tests are running against a cluster that was stood up for the duration of the job, like using some bash. And so those VMs are not running anything else but the tests, and are like should be large enough. So also one thing that could happen is like if you saw this spike more over time, we might have had a regression in one of the components. We've upgraded a lot of things in that cycle in pretty big ways. This one's always
Gotcha.
fun. These timeout things. It's hard to say like, well, like what really failed here.
Yeah, this is where I always get stuck, is I want to get folks digging in and figuring it out, but
Yeah, and a
where to
lot of these
begin.
tests just say like timed out waiting for the condition, and you're like, well, what was the condition? Yeah, it's one of those things where like we have some generic matchers, and a lot of the tests don't really tell you. So it takes some time just to even find out like what might have timed out.
So I know for our tests, it is the condition is waiting for a BusyBox pod to spin up, or it's HTTPD, or some very simple small pod to spin up, and that's the condition that's timing out.
Yeah, I mean, it might be something in the in like the container runtime, or what are we running in this job?
So is that just like surfaces like context deadline exceeded in the pod?
So
Look at the pod and see what the error was in the pod. Is that what we're seeing here in this log file example?
we're seeing that a deadline was exceeded waiting for the pod to be observed ready. Like the test was waiting.
Are we one thing, like we were hitting this, like we hit this a lot, and we got those errors down by making sure that we're clearing out the pods, you know, the finished pods. Are we doing that in the clusters?
I think tests may like tests are expected to clean up after themselves, but can't necessarily guarantee. And like we're running concurrently, so we have like in threads of running through the test cases.
But yeah, if you leave those jobs laying around even after they're done, it can bog down Kubernetes. At least that's what we've seen, and we're running an earlier version, though. We're running 1.16.
Yeah, I mean,
actually, job that we have like an operator that we have running that just removes just anything out older than 24 hours. Just delete the pods.
The infrastructure itself, the persistent parts, not the like test cluster we've brought up, but we tend to call them build clusters, that like sort of just workload pool that we're using to execute like running the tests and things like that on the CI. Those run a component called Syncer that does pretty much that. It has some awareness of the job abstraction, so it can choose to keep around maybe like one instance, the most recent run or something like that. But it pretty much goes through and delete all old pods, because with our jobs we were running into, they tend to write to like just ephemeral pod storage, and building Kubernetes for even just a single architecture, if you build everything in the repo, could be like 30 gigs. And if you have a whole bunch of jobs doing that, pretty soon you just run out of disk on the CI machines, since those aren't released until the pod's actually deleted. We had pretty excessive issues with that. But that would not be super expected during an end-to-end test. I would say that generally these end-to-end test clusters are like a little over provisioned, and that's one of the reasons we were doing kind of like, well, we can probably test most of the stuff just with some little tiny simulated ones. We don't really need like a full-blown cluster to run. Like, can you use kubectl to run a pod? Like that would be super cheap.
Yeah, like I don't know if the GCP has the equivalent of standing up a cluster with spot instances, something like that, maybe. I don't know.
Yeah, we have some like that, but we're still kind of just using, most places are still using whatever the config was years ago for the defaults for creating a test cluster. So they're, for most tests, they're probably like a little bit more than we need. I And that is helpful because we can clear signals. So when we're having all these timeouts, the first thing I look for is, did the job timeout? Like, did we reach just like, we have a bunch of tests that didn't finish because we didn't finish running all the tests. But that doesn't appear to be the case in this instance. And you can see that they're just, you can see if you scroll through just like the whole log, you can see them timing out throughout the.
Yeah.
So it seems to me like more of a, like there's something systemically wrong with just like starting pods in these clusters.
Right.
Which is surprising because like we might in the past have blamed like, oh, well, this is one of the jobs where we switched to like containerd or something and it wasn't like there's some bug in this version because it's an early version or something like that. But this one's running Docker. And we don't upgrade it super often, but it should be pretty stable. It looks like we're running 1903.09, so like a pretty patched version of like a pretty stable, pretty commonly deployed Docker version. And it probably hasn't changed other than the patches for some time. So
out of curiosity, like you went through the list, but not everything is a timeout. And are the other things, like I see should not be passed when pod info mount equals null, or flaky, kubectl explain blah blah resource name is built-in object. Are those significant in any way? Or
the flaky tag is that's one that's manually added to jobs that like we've decided like this is known flaking, we don't have a solution. And the main purpose of that is for example, the tests that we run on your pull requests to Kubernetes, they exclude any tests that are tagged flaky so that we're not like wasting everyone's time with, okay, we know this is flaky and like we don't have a fix and maybe we don't think this is the most critical text, so we're just going to tag with that. We can let it run in this periodic CI job over here until someone fixes it. So the fact that a flaky test failed, like not surprising, but that we have all these other tests that aren't tagged flaky that are like timing out on, like Eddie said, some of these things, if you dig through it, you can see they're just waiting for a pod to start. Yeah. That's, I mean, you can imagine like if in your production cluster, you tried to schedule a BusyBox pod and you waited a couple of minutes and the BusyBox pod wasn't ready, you would be concerned.
Yeah. Right.
So kind of the same thing here, even though this is like a weird test cluster on some test version of Kubernetes and we're just running test workloads, you would still kind of expect that some super cheap pod would just come up. One of the things we can also do, there's a link at the top, artifacts. Artifacts is, we populate an environment variable when we're running these jobs. It says like, put things here if you want them to be preserved. And then the test will do things like dump all the cluster logs under that directory. And at the end of the run, the CI will like upload all this to GCS. So if you click through the artifacts, the first thing you see is like the actual metadata that the CI uploaded, the build, the log of the test, the pod that like there's a JSON format of like the pod that we were actually running to run the test and that sort of thing. And there's again an artifacts directory.
Yeah.
Another little tool the project built for like viewing our results. And under there, you can see a couple of directories that look suspiciously like node names because they are. And those have all of the system logs. So we can like look through this. So that's how I will say like, oh, this test cluster is running Docker. We're not doing anything exciting. Like maybe it's one of the jobs where we're running a super recent version of containerd because we're trying to test the latest run C to qualify it against Kubernetes like collaboratively before the project's release. We're not doing anything like that here, but you can see that because we have all the like system logs. So
See that, yeah.
Like here, you can see the logs for the control plane node. It's also a small note there. This is using the super old bash tooling that no one in the org really wants to own. called KubeUp that's still in the Kubernetes repo. And so it has some pretty archaic things like naming nodes master and minion, which are both terms that are not used in the project anymore, except in this thing, because even though it runs like most of CI, pretty much everyone just wants to pretend this stuff doesn't exist anymore and delete it. No,
How hard would it be for us to add alerts? Like if we wanted to test the disk IO theory, I know Eddie, you have access, or is it read only? It doesn't sound like someone who can add like, oh, something, just check disk IO and then send an alert if it hits it.
So if you wanted to add something like that to the infrastructure, like it's, all this is just like managed through like GitOps anyhow. But in this case, this job is not, it should not be really using disk on the shared infrastructure. It's creating a cluster just for the purposes of testing and scheduling us that. There's no other workloads, only the test workload. So
it's a cluster it's creating. It's a cluster it's creating that's actually the one that's timing out, right?
Yeah, and then the cluster it's creating has like, in this case, that master node that is running the control plane and is tainted. So none of the test pods should be on the machine that has the etcd. So even if they were writing the etcd heavily, like there's nothing else happening there. There's just like it's running clusters etcd, so it should be able to keep up. Whereas we have other tests we're running kind clusters, which is one of our SIG subprojects, where their Docker containers are the nodes for the clusters, and they're running on the cluster is actually running in the CI cluster at the moment.
Mm-hmm.
So you might also have like some CI build like co-scheduled to the VM that is running all of the nodes of the test. So that's what I originally thought referring to. And something that is tracked is we should look into like sort of what happens if we just throw more IO at this problem. But in this case, we've been running this sort of thing for a long time. It runs its own ephemeral dedicated infrastructure, and there's no reason it should be having like disk IO issues to schedule a pod or something like that.
Unless it's a bad test, right? Something consuming all the resources.
It's possible. For example, we've had some things hammer the cluster pretty hard, but they usually don't show up that easily in this kind of job because, like I said, it's maybe a little bit larger than you really need. Like most of the tests don't need much, and this is a totally dedicated machine. Like nothing else is running on these VMs, just the Kubernetes itself. But we have had things in the past that showed up like more heavily on like those kind clusters where they're running on a shared, possibly like under provisioned VM. And we had things like at one point there was a sidecar in the CSI testing that monitored like all nodes, all pods, and like a number of the core resources that was like watching all of them pretty aggressively and like increased the load on the cluster, and then that caused tests to flake and we couldn't like relate them to anything else. So that's where like the triage dashboard comes in, and we can say, okay, we can see that we're just having a bunch of random failures increase in these jobs over this time frame. So since they don't seem to match up to anything in particular other than the time frame, what did we change in that time frame? So that might be what we have to do here.
Is there things like looking at the actual storage pools underlying, where so if multiple jobs are talking to storage pools, that we see that contention doesn't come from disparate, so a different workload with completely unrelated things going on that disk? I assume they share a fair amount of that. Is their way to look?
No, there shouldn't be any, because so these are running on ephemeral clusters that are GCP VMs, so they have their own like disks that the cloud provider is guaranteeing, like here's your disk. In reality, those are like abstracted disks that are over the network and stuff, and there's more things going on, but we haven't observed any issue like that. Like even if it turns out that like part of how that is ultimately backed is shared, like there are other systems between us and the disk that like make sure we get the IO we're supposed to get, like the throttling of someone else's workload.
Okay.
So what we were seeing is like when we're running these kind clusters, or like builds or some workloads like that, or like there's some integration tests that like spin up just a couple of the components directly, and then run tests against them. Those are running in the CI cluster. And then in the CI cluster, we may be like ourselves co-scheduling workloads to one of those like virtual disks. So I want to also, before we finish here, I want to find a doc and link it to you all. Since we've kind of wound up on the just general topic of flaky test debug, we actually have a doc. Kubernetes, I think it's in the community repo. There's a doc that one of our members wrote that's sort of just about like how to do flaky test debugging in this project, and it's quite good. There was also we've also got, I think there's a video from Jordan Liggett came to one of our meetings and gave sort of like a little talk about this, since he does quite a bit of it. And you can also watch that talk. It's linked in the doc. We have a lot of tools that can be used here that this goes into like more detail on. But for all of it, I'll say that a problem like this is still kind of the hardest, where it doesn't obviously seem related to anything. It's across multiple different tests. They don't appear to be doing anything crazy. The infrastructure is like boring old stuff we've been running for a long time, other than the Kubernetes version. So that makes me say that like probably we want to look in the direction of like, did this get worse over time, and can we like pinpoint when that was and look at what changes happened in that time. But you know, going through all of those motions will probably first requires like getting a little bit up to speed on like, okay, how do I look at the tests over time, and how do I know what versions they were running and that sort of thing. And there's quite a lot to unpack there. This doc covers a fair bit of that.
The flaky test doc.
Mhm.
Yeah.
Like the triage dashboard itself is a very powerful tool, but it takes a little bit of like getting used to, and it, you know, it doesn't have much in the way of docs or explanation about things, or like tooltips, and it ties back, you know, pretty heavily to like our concepts around like what is a job and like what is all the metadata we have around it, that sort of thing.
Yeah.
It's pretty much a power user tool that like a handful of people depend on pretty heavily, but it's like hasn't been optimized for like bringing new folks on board to it. So I'd say this talk and this doc are like the best resources for like getting up to speed on that, if you're interested.
Yeah.
Sorry,
And which talk are you referring to? Is this one in the meeting notes?
The
Or is it in that doc?
flaky dash test doc that's in the community repo. I think that it's not that. I think that was like his one. The current doc is here.
Marina, I think Marina gave us a link.
I threw a link to these notes in the agenda as well. I will probably clean them up afterwards, and post them somewhere less ephemeral than a gist. But if you want to follow along, or if my screen is not working well, that link is there for you. So
Didn't realize you were here. Hi. Did we lose him? Oh, this is
That was
someone-
that was a video. I accidentally hit play in the video.
When did Jordan join the meeting? I didn't
My bad.
If good sound, I it's like, wait, I'm so confused. Well, thank you all for coming. I will try to find some time soon. I need to follow up on a couple of things at work, but I'll try to find some time soon to like surface some more of these resources. And if you are looking for anything, feel free to reach out. For the most part, at the moment, I'm probably going to point you to the project boards to start. But if you don't find anything, follow back up. And just in general, like ask questions in our Slack. Everyone's super friendly and helpful. And there's probably someone else that wants to ask the same question, but hasn't yet. So
Thank you so much.
thanks for coming. Have a good rest of your Tuesday.
Yeah, y'all too.
Thanks for sharing.
Yeah.